The two problems compound, and the ultra lightweight rim compounds it even further. So it's like a three-pronged carbon death wish. You will see when you put tires on those, funny things happen. They go out of true, they lose their shape, and they lose a lot of spoke tension just by having a tight tubeless tire. So hi everyone, and welcome back to the channel. In this episode, we're going to look at what these two small models have to do with carbon fiber wheels and why I think the industry is straying off the path a little bit again. And then we'll look at some tubeless tech, which isn't in cycling yet, but if it does come into cycling, and I predict it will do, if Conti and Hankook, or if we can persuade them, I think it would solve all of the annoyance with tubeless on gravel, mountain bike and road. That being sealant drying out, it's expensive, and not being able to balance the wheels. And yeah, this could, I think, solve all of that. But we'll come to that later on in the video. Now, just a quick recap. In the last video, we looked at the dangers of non-captive spokes in carbon fiber wheels using carbon spokes or even steel spokes without captive, spoke entries into the hub. And we looked at how basic design principles just weren't there. So FMEA, and on Patreon, actually, we went into a deep dive and did a rated FMEA, and the scores were just horrendous. It should never have got off the drawing board with scores like that. And it just kind of goes to show like the naivety of how these things are designed. They're just not really thought through properly. So we'll try and leave that non-captive spoke thing behind. I won't keep mentioning it. I have been mentioning it for about 3 years. But in this video, we're going to continue to look at carbon spokes. And I think some of the design principles that should have been used just basically haven't been. I think they're missing or forgotten or ignored. And they came in about 3 to 4 years ago. I think my first pair of carbon spoke wheels was about 4 years ago. Now, in another article, like a deep dive article on Patreon, we looked at basically how much carbon fiber spokes stretch. And we did a simple numerical model to determine spoke stretch of a steel spoke versus carbon, and looked at how actually it's very closely matched to the test data. So sometimes when you're working with carbon and theoretical models and numbers, it doesn't actually match the test data. But because a carbon spoke is basically unidirectional, there's hardly any resin in it, the Young's modulus or stiffness modulus of the carbon spoke can be very similar to what you actually test. So the numbers match the test data, and in that we found that basically carbon spokes somewhere between 30 and 50% stiffer in elongation than a CX-ray spoke. Now, the problem with that is, yes, it makes the bike responsive, feels fast, feels snappy, and all these stupid keywords, also makes it fucking uncomfortable. They have 50% less stretch. So if they're 50% stiffer in elongation, they're stretching 50% less. And that's a real problem. And the basis of this part of the PT show, we're going to talk about why spoke stretch is vitally important. And it's a key design trait of anything designed in a dynamic system, whether it's a suspension bridge, cylinder head on a car, or a wheel suspended by spokes in tension. Stretch is really important. And I think it's been forgotten. And I think it's giving us future issues, I predict. And another thing to remember is spokes, whether they're steel or carbon, have virtually zero compressive stiffness or compressive strength. And they can't resist buckling, which is what these two little models I've made are for, and we'll come to these later in the video. So why is compression a really important thing here? So whilst the wheel or suspension bridge, which we'll come to that analogy, is in tension, and all the spokes are in tension, everything is fine. Everything works as it should do. The wheel feels stiff, it feels responsive, but carbon spokes are very unforgiving in compression. They lose 50% more tension for the same rim displacement than like a steel or CX-ray wheel. Now, caveat, there are carbon spokes which match stiffnesses and elongations of steel or CX-rays. We'll come to that. This ultralight rim that we're coming to, so the sub 1,000 gram wheel sets at 50mm D, plus super stiff carbon spokes is like the perfect storm, and the system is actually the wrong way around dynamically if you think about what the design issue is here. So how much compression is seen on a spoke comes down to rim stiffness. Rims are getting lighter. There is a push for 1,000 gram wheel sets, like I said, 50mm deep wheel sets, sub 1 kilo. And I don't think it's the customers that are pushing this. I don't think it's you and me. I think it's basically the literal hundreds of Chinese brands and factories trying to outdo each other and willy wave, but it's creating the perfect storm. Flexible rims and uber stiff spokes are not dynamically stable, and we've seen the problems. Like, just the tip of the iceberg of this problem is when you mount a tight tubeless tire like a 5K TR on a lightweight rim with stiff carbon spokes, they lose a lot of tension. Why is that? Because of lack of spoke stretch. So lightweight rims, moving on kind of down the road of the problem. First of all, imagine a rim without any spokes. So if you imagine one of these outer rims without any spokes, a light flexible rim section will deflect more than a thicker, heavier, deeper one. In a fully built wheel, that deflection is passed onto the spokes, which can't resist any compression, remember. So bear with me, moving on. What happens if that spoke tension then drops to zero through a big impact, a compression, pothole, a crash? Worst case, the spokes will pop out of the hub due to open pockets, which we discussed in the last one. I said I wouldn't mention it again, didn't I? But I just did. Best case, the wheel becomes dynamically unstable. Now, in my first Elite Drive review about 3.5 years ago, we saw this under hard braking. The leading spokes coming out of the hub, so the ones not doing the braking transfer of torque, were detension due to braking torque. And I proved that by showing kind of harmonic analysis of those spokes under normal tension versus their loss in tension and plucking them whilst braking, whilst torquing the wheel. This isn't so bad as the displacement is not really deflection driven here. It's more governed by the rest of the wheel stiffness and the spoke stiffness. The twist of the hub is dictated by the stiffness of the trailing spokes, but we still saw those spokes detensioning quite a lot because of their inherent lack of stretch. But what is displacement driven is an impact on the rim, crashes, potholes, and these displacement driven impacts, so far as the zero compressive stiffness spokes can see it, comes via the stiffness of the rim section or the lack of stiffness. So if you look at this wheel, if you have an impact on the rim locally, like at the bottom when you're rolling over something, that will bend. That rim will bend, right? And those spokes, because they're all in tension and they have little compressive stiffness, they can't resist that rim bending. They can resist the rim egg shaping, but locally, they can't resist the rim bending, and that can put spokes in the immediate vicinity of that rim impact into serious compression, and carbon spokes being so stiff, 50% stiffer than steel spokes on the whole, in my test, will lose tension very, very quickly. So what happens to a spoke when it loses all tension? Now, I hope you are following me on this, because this is getting quite geeky. If you imagine a suspension bridge with all the steel cables hanging the road deck in kind of static equilibrium, if you have ultra stiff hangers or ultra stiff cables, 99% of the time that's fine. Like your carbon spoke wheel, 99% of the time that's fine. However, if the rim deck, through an earthquake, tornado, some weird traffic event, was to get any lift on it, and those hangers of that bridge had very, very little stretch, the road deck, i.e. the rim in this case, would become dynamically unstable. The instantaneous loads in the other spoke members would be very, very high. So it's important for those cables to be so elastic that the road deck can actually move up, go down. All of the time, those spokes, those members, those hanging members must be elastic enough to absorb all of that movement. And this is the problem with carbon spokes. On flexible, lightweight rims, they can't absorb that moment. And we'll look at these two little models now to try and assimilate that. Now, this is a very, very extreme case. We've got a very, very elastic spoke system here, and the hub is completely suspended by the elastic. And then we've got our carbon spoke version here, where basically these spokes are, compared to this one, almost infinitely rigid, have very little stretch. Most of the time, all the spokes are tight. Everything's honcho dory. But if you squeeze that rim or give it an impact, even a slight bit of deflection on the rim causes them all to come loose and the wheel is not stable. If we do the same compression on this, all of the spokes stay in tension. And that's just like the suspension bridge analogy. And I don't think this is being thought through enough by the brands creating these very, very lightweight, flexible rims. And I'm saying flexible, I'm sorry, they are. If you're making 1,000 gram 50mm wheel set, there's no new materials that you're using. There's no very new technology going into these rims in terms of the carbon. So you are just taking away carbon at some point. Yes, you're doing more machining on the hub. Yes, you're using a carbon spoke, which is very, very light. But at some point, the rim is going to have to be lightweighted. If you lightweight the rim and the section depth and the second moment of area doesn't change, that rim is going to get more flexible. It's going to pass more compressional loads to the spokes, which can't hack it. And these spokes, let's say you put 100 kilos of tension in your SAP MCX spoked wheel versus your carbon spoked wheel, that 100 kilos will cause about 1 millimeter of stretch in your Sapim CX rays. The same 100 kilos will cause 0.4, 0.5 millimeters of stretch in your carbon spoke. So you only need that rim to bend down 0.5 millimeter in an impact and you've lost all the tension in one spoke. And this is just compounded by the fact that most carbon spoke wheels are actually using less spokes. Now, if you look into how a spoke is loaded as it rolls along, the loading on the spoke is sinusoidal. It's basically fully reversed load cycle. And if you don't know too much about this, I'll try and explain very briefly. A fully reversed load cycle is probably the worst load cycle in terms of fatigue stress. So if you've got, let's say your baseline is 0, you load the wheel up to 100 newtons one way, you take it down to minus 100 newtons the other way. It's basically pulling and pushing, but going through 0 as your middle point. And if you take your offset stress as your spoke tension, when you roll along the wheel, along the floor, the loading in the spokes is fully reversed and sinusoidal. If you have less spokes, the amplitude of that sine wave, so the amplitude of the loading at the most extreme point and the most extreme negative point, is higher. Which is why if you are wanting a wheel set to last, just because you don't put any more load on it, if you want a wheel set to last with maximum fatigue life of the spokes, you increase the spoke count. Some of these carbon wheels have got 16 spokes. So the sinusoidal amplitude goes up to shed. That's how spoke tension is shed. Yes, it changes with ride away and blah, 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 blah. And one defense of having less spokes in a carbon wheel is that they're not overly stiff. I agree. So generally the carbon spokes are much stiffer, but they will become less stiff in a system if there's less in the wheel. However, like I said, what they don't tell you is the stress amplitude is, sinusoidal amplitude is much bigger when you've got less spokes. The more spokes you have, as the spoke count kind of goes to infinity, that sine wave almost goes to flatline, but it never will because you've still got discrete number of holes and spokes around the rim. Anyway, that's by the by. But what do you think about this? Like anecdotally, here's some real world elongation data. The blue line is a carbon spoke, the orange line is a CX ray, so your standard steel spoke, and the gray is actually a titanium spoke. But going forward, out of any carbon spokes that I'm testing, or I mean, I'm still testing, I'm still interested to see if we're going to get to this stage, I will be looking for carbon spokes that are actually matched to CX ray stiffness. I don't want to see companies bragging about how stiff they are, how much stiffer they are, and how little elongation they've got. If they've got little elongation, that's a massive red flag, because we'll end up with this super stiff system where any deflection, like at the moment, this is stiff, there's no vibration, there's no dynamic instability. As soon as you start to compress the rim, it starts to come loose. Right? This system does not, because there's lots of compliance built into this. I'll be looking for something that's got, if it's got carbon spokes, they're doing it to save weight, that's fine, but I'd rather have it to be stable and fully elastic through any load condition. Now, you mustn't forget that the UCI has a wheel test. So a lot of these young brands, and like being a wheel tester, I get 5-6 emails per week from a Chinese brand I've never heard of offering me to send their wheels and test them. Say the UCI approved. The UCI approved wheel test is not worth the paper it's written on. It's a 40 joule drop test. Now, if you figure out the height of the weight that is dropped on a rim just to make up 40 joules, it's a very, very easy to pass impact test. So don't be fooled by the UCI legal or the UCI validated drop test. It's absolutely crap. You need that wheel to be as stable as possible through any loading condition, which is why I prefer elastic spokes that stretch a lot, not just for comfort, but for dynamic stability when something goes wrong, like you hit a pothole. Now, the fact that we're seeing so many of these wheel failures happening with the open, like in this special wheel design that I've made, the carbon spokes, this wheel represents the carbon spoke, by the way. This is my CX ray model. The problem we're seeing where, and yet another crash has come out this week where straight pull side entry spokes have popped out of the hub on this KDEX wheel. The problem with these really stiff spokes just exacerbates that. So you only need a tiny bit of compression at the rim to completely detension that spoke. When that spoke is completely detensioned, it will just pull out the hub sideways. So the two problems compound, and the ultra lightweight ring compounds it even further. So it's like a three-pronged carbon death wish. And I'm not trying to piss on anyone's product design here, but just chasing lightweight and going ultra stiff spokes, it's the other way round. Really, if you want to do this properly, you'd make an ultra stiff rim and have spokes still as the elastic members. Anyway, I hope this is clear. I feel like I've gone through this in a strange method, but what do you guys think? Are you worried about carbon spokes? Like, again, there's another crash was sent to me. A Cadex wheel has also had an impact. Spokes have lost tension very quickly, and because they're not captive, they pop out. So I predict this problem is worse on rims which are shallower, because a shallower rim section, so like a 30mm really lightweight rim, won't have as much section stiffness. So if you look at if you chop that rim profile in half and looked at the depth of the rim, deeper rims are inherently more resistant to bending by roughly the power of the cube. The centimeter area goes up with the depth of the section cube. I mean, it's difficult because it's a teardrop shape, not a rectangle, but in general, they're a lot stiffer. So the worst I think you can do is have a very stiff carbon spoked wheel which has a very shallow rim. And I think you will see when you put tires on those, funny things happen. They go out of true, they lose their shape, and they lose a lot of spoke tension just by having a tight tubeless tire. Why these wheels lose tension when you mount tires on them? Well, this is why. There's not enough stretch in them at their starting tension. So even a tiny bit of hoop compression by the tire can cause the whole thing to come loose. Well, start to become loose. And then if you're down 50%, or if you're down 30% tension to start off with, there's then even less stretch left before you get dynamic instability and things start to come loose. Anyway, I hope that's kind of clear. The next thing I want to talk about is a tubeless technology that has been in automotive for a while, and Conti do it, Hankook do it, and Eric Pirelli, I think, do it as well. But we'll concentrate on the Conti one, just because it's the easiest one to look at. It's called Conti Seal. And what this stuff is a tubeless sealant that is basically static, and it's painted on the inside carcass of the tire. And then when you get a puncture from a nail or a stone or whatever, or a sharp, as that thing comes out, that really viscous sealant plugs the hole. And why would this be advantageous to cycling? So A, it doesn't dry out. B, you can balance the wheel. And the reason why car tires don't use normal liquid sealant is because the balance would be horrific. The vibrations coming through the car would be horrific. It would wreck your suspension joints. The steering wheel will be wobbling all over the place. But on bikes, we kind of put up with it because you can't really feel lack of balance when you're bombing down a gravel path. But when you put the bike in a stand and you spin your tubeless wheel and it's partly dried and clumped up, it's all over the place. So that would be a reason to go for this. Now, why don't we go for this? Why have we not seen this in bikes? Because I think it would solve those issues. It would solve the sealant drying out thing. It would solve the impossibility to balance. And replacing like a decent tubeless sealant like Orange Seal is really expensive. It is really expensive. I mean, yes, it saves you a lot of inner tubes, but it's still pretty spenny. If we had this kind of solid or semi-solid tubeless technology in bike tires, it would just be amazing. Like, you wouldn't ever need to replace the sealant, and you'd be able to balance the wheels. However, I predict the reason we aren't seeing it is due to weight and rolling resistance. The added rolling resistance of having the thick viscous layer in contact with the tread, which in bikes deforms a hell of a lot, probably more than it does on a car tyre, would really hinder your progress, although no one's tested it. With a liquid-based sealant, that sealant isn't being asked to hysteretically deform every time you roll the tyre. Every single time that tyre is in contact with the ground, the automotive-based solid sealant is deflecting, it's heating up, there's frictional losses within that. The rolling resistance probably would be pretty high, but I'd love to see it tested. So if someone could if Conti, if you're watching, if you could get me some of this paste or paint it inside a Terra Speed tyre, and we'll do some rolling resistance tests down at Silverstone. I'd love to see the outcome of this, because I think it could be game changing. And if you're not worried about rolling resistance, like if you're doing epic, cross-continent, long-distance rides, I would probably put this in the tyres. I think it would save you a lot of money in sealant and inner tubes. So that's my prediction. I think it will come. I don't know how it's going to work with the roll resistance thing, but I'd love to test it. So anyway, I hope you enjoyed that. If you have got any more questions about these little models and what they depict, let me just say that again. This is the CX-Ray one, where basically even when you compress the rim over impact, all the spokes stay under a nice stretch because they've got a high starting stretch. And this is the dynamically unstable one as soon as you get a rim impact. And the spokes and the hub can rattle and come loose and pop out sideways. I said I wouldn't mention it, but I did. Anyway, hope you enjoyed that. More in-depth articles on the design of wheels. Like I said, the FMEA study that we did on pressurizing rims, so rims without the vent hole and the side entry spokes, the scores were just off the chart. They wouldn't have got through. If FMEA was done in the design process, these wheels wouldn't have been launched. So I hope you enjoyed that, and I'll see you in the next one.